Right, welcome back to the next session of ID24. We're at the 16th session now of the day. ID24 is brought to you by the Paciello Group with kind support from Barclays and the Center for Inclusive Design. And you can find out more about those organizations on our website. If you like this session, hit that like button and subscribe to the ID24 channel for future event streams and videos. We'd also like to take an opportunity to say a quick hello and thank you to organizations who've decided to host their own local ID24 event. Currently, we should have Sapient Razorfish in Germany, streaming from 4 of their locations, as well as Q Delft in the Netherlands, streaming from 2 o'clock till 7 o'clock UTC. Now, don't forget to send questions for presenters by tweeting to the ID24 hashtag. We'll pass on these questions to the presenter at the end of the session. And for each session, the best question will receive a free 90-day JAWS license. Also note that on YouTube, we have enabled the chat, but we're not monitoring it for questions for the presenters. It's literally only there for participants to just chat amongst themselves. So without further ado, I'll pass over to Almero Steyn with his session on tips, tricks, and tools for building accessible React websites. And over to you.
Well, awesome. Thank you very much. And hey, welcome everybody to the session on tips, tricks, and tools for building accessible React web apps. As you know, my name is Almero Steyn, and I'm super excited to bring this as part of ID24. I work at a company called Q Delft in the Netherlands, and here we do some projects for Dutch government where accessibility is, of course, a requirement. So you can find me on my blog. You can follow me on Twitter. The Twitter handle is on screen there. And I also like to give a warm thank you to Kalina for providing some awesome graphics for my talk today. So let's jump right in. And we're going to start right at the beginning. I assume that not everybody tuning in today are necessarily React developers. So I'd like to set the scene first for what, why are we trying to solve the issues that we are trying to solve, and what is the state of React and accessibility out there. Now, React itself is a JavaScript library for building user interfaces. It was created at Facebook by Jordan Walk. It's also open sourced, which means that it is used quite prolifically out on the internet. But who uses React? And on screen now, you can see a couple of well-known websites that either use React internally or are completely built in React. Of course, we've got Facebook using React in the Facebook software, Netflix, Airbnb, Instagram, the WhatsApp web interface. Great to see Tenon there. There's an accessibility-focused website using React. Got Wekamp, which is a major online Dutch retailer. Also, the BBC uses it. And this is far from an exhaustive list, of course. This just goes to show the level of websites that are using React. The list is quite long out there, and React is not going away. Oh, and by the way, I don't know if you've noticed it, but even Westworld seems to use React internally. If you look very closely, you see some React code. But how accessible are these websites out in the wild? And for those who cannot see the screen, there's a movie poster of the good, the bad, and the ugly on screen right now. And we are going to start with the bad and the ugly as the first examples. Now, I'm not going to be naming and shaming any specific websites in this talk. It's not the purpose of it. You know who you are. So we're going to go straight to a quote from a WebAIM article recently. And what WebAIM has done is they've run automated accessibility audits over the Alexa top 100 websites, first in 2011 and again this year. And what they found was that the number of errors found by these audits increased by 60% over 5 years. Now, well, that's quite shocking. And one of the reasons that they give for this increase is possibly the use of JavaScript tooling, libraries, frameworks like React. But why should this matter for accessibility? And on screen, we've got this cat looking very, very confused, as I'm sure that some of you may be. And let's dive a little bit deeper to try and see where these ideas come from and where the actual errors come from. Now, on screen right now, you see a little bit of React syntax. it's JavaScript. We see a JavaScript function returning something that looks suspiciously like HTML. And yeah, JavaScript, everything in JavaScript. And we've got quite a shocking situation for some people. In fact, we've got a koala bear on screen spitting out its leaf lunch, so shocked that everything gets returned from JavaScript, including the HTML. Also, what we are finding out there is that React is so powerful that you can quickly change normal elements to do something that they were not supposed to do. And on screen, we've got Harry Potter performing a div-to-button cadavra spell. That, of course, means he kills it. And we see some code there with a div that gets some CSS over it to make it sort of look like a button. It gets an on-click handler, and the developer thinks, hey, I'm done. This thing works. But of course, that is very far from a button. And these kind of examples, we see quite a lot out there in the wild. And that, of course, you will be forgiven to think that that means that JavaScript-Zilla totally destroys accessibility. And here we've got the Godzilla of JavaScript stomping through accessibility town, tearing down all the accessible buildings in its path. But what if it was to tell you that quite often this is just a thing of knowledge of how do I apply these tools? How do I harness the power to make something better? And I can tell you that you can make quite a friendly little accessibility monster out of all of this. We also need to go back to the good, the bad, and the ugly, and also focus on the good, of course. And as example, today I will show you a screen cap from tenon.io. And of course, this website is not only an accessibility auditing website itself, it is also super accessible in itself, and it uses React. So this is a perfect example of what we can achieve when we build things using React. But of course, we want to know how, and that is what we're going to look at now. In the first section, we're going to look at some tips and tricks to get up our sleeves to make our React applications as accessible as possible. What I've also done is I've created an example application. This is on my GitHub profile, so github.com/Almero Steyn/React-A11y-patterns. If you go there, pull down this repo, you get functional code that has a lot of the fixes, tips, tools, and tricks in it already. The reason I created this application is because I want to show you that this works in actual code and not just on static slides in my presentation. You can pull it down, follow along, or later re-look at the video and have a look at how it is implemented in the code. It's a very basic application. It's a to-do application, but it uses techniques that I have found to work in real-world applications and in large applications with code bases of more than 10,000 lines of React code. So let's dive right in. And I think before we try and see what we need to solve in a React application, maybe it's handy to first see of why we are facing these challenges. And firstly, we have to look at the React component tree. And that is how we build our React applications. We build it with reusable components. Now, what is a component? Component is basically a little bit of reusable front-end logic and view. So you can think of it as a container of Lego blocks. If I create a labeled input once, I can make a component out of it so it's properly labeled, and I can reuse it everywhere in my application. It makes the application easier to think about. It speeds up the development of the application, and that is really one of the benefits and the reasons of why we use React in the first place. If I construct my component tree, what I get is that parent components talk to their child components by passing data into them. Child components talk to their parent components by bubbling events up. And so I get this composed component tree of reusable components. Sometimes the same component is used multiple times in the tree, and that becomes my React application. How do I create these components in React? I have two ways. The first one is just with a JavaScript class, and that is a React component class, and it extends from the React component class itself. And what I see is that this component returns some view. And every component, typically, almost every component out there, returns view from the render method of the component. I use the class component if I want to do more computational things, if I want to have internal component state, if I want to have event handlers. So this example here is really just small, just to give you a taste of what a class component is. I can also create components with a component function. And that is nothing more than a JavaScript function that accepts a parameter, and the parameter is a collection of properties, or props as we call them in the React world, and this function just returns some view again. But how do I construct my component tree now? I do that by reusing these components in the code. Here is some example code. You can see that I previously created a demo component. This component is then exported from its own code file, and when I create a new component, in this case I call it root, I can import the demo component and just use it in its view portion. It brings all its functionality and view with it very easily. Once I've constructed this, of course, what I need to do still is, okay, I've got my code, I've got my component tree. How does it end up on my screen in a React application? And that happens in the following way. Once I've constructed my code model, when it loads in the browser, React will parse that code and construct a virtual JavaScript DOM for us. This is then painted onto the browser by creating a real DOM that mirrors the virtual DOM. So in every React application, we've got two versions of the DOM active, a JavaScript version and the actual DOM that you see. But why are React applications then so fast? If I have any changes in my model, the virtual DOM will instantly be updated, and then a clever program called the reconciler will go through the virtual DOM, compare it with the actual DOM, and it will only patch those changes into the actual DOM. And this is super fast, but of course, what really is nice about it is it leaves the actual DOM pretty much intact if you think about these changes that you're making in your program very well. What does this virtual DOM actually look like? Now here's a screen capture of the React Dev Tools in Chrome browser showing the React virtual DOM of an actual application. Now you see, once again, this kind of sort of looks like HTML stuff, but it's not HTML because I know live message and labeled input does not exist as elements in HTML. I know that ref and HTML4 are not valid HTML attributes, but this is basically a one-to-one translation of my React component tree. When this gets rendered into HTML, though, this is what I get. And what do I see there? Nothing but clean old HTML. And that is really a secret in creating accessible React apps, the fact that I can create clean old HTML. I mentioned a lot about this stuff that kind of sort of looks like HTML, but what is that really? In JSX world, it's called in React world, sorry, it's called JSX, and it's nothing more than HTML-like syntactic JavaScript sugar, and it means that under in the motor of the React application, this React DOM is actually built up by JavaScript instructions. Now, JSX enables us to think about these JavaScript instructions in a way that in the same way that we would think about HTML. So here you see a small example, a labeled input. At the top you see the JSX version. At the bottom you see the HTML version. And you see that it looks very much similar, but different. So we've got, for instance, HTML4 that translates to 4 in the HTML. And the reason for that is that 4 is a reserved keyword in JavaScript. We also see the React braces that allows us to put variable data in there. And this eventually renders the value of the variables into our HTML. And because we know that JSX relates so closely to HTML, the first rule of ARIA still applies in JSX. So it's a bad idea to create a div that looks and kind of half functions like a button, because there is a JSX element that is button. And while we are talking about ARIA, it is very important to know, and really great, that all ARIA attributes are valid JSX props. So that means that they exist in the React spec. I can use ARIA just the same way that I would use it in HTML when I write a JSX code. And the great thing about it is because it is supported and specified, I often get IntelliSense support in many of my IDEs when I write my JSX code. So you're not totally in the dark when you write JSX. You get a lot of accessibility support in IDEs in one form or another. So to wrap that up, it really just means that good JSX makes good HTML. And that really, I would say, counts for, they say that 85% of all statistics are made up on the spot, but in this case, 80% of your accessibility of your React app comes from just writing good JSX. In this snippet of code, I see that I still get my semantic elements, just like I do in HTML. In fact, every HTML element has a related JSX element. So I can really just think about my application in the same way that I normally would when I write good HTML. What of course differs as well is that I can reuse components in my JSX. But think about it now that this component, if inside of this component, it just contains JSX that renders to semantically correct HTML, I only have to think about the composition of my React component tree to make sure that my entire application eventually renders good HTML. So really, that is all accessibility of React applications start there. Just apply the rules that you normally would in HTML to your JSX. There's been a number of talks today already on the matter. These rules are all transportable to the React world because at the end of the day, the JSX that I'm writing will just render to plain old HTML in my browser. Then a little trick, fragments in React 16. Now, you may or may not know that recently React was rewritten from the ground up, and that is called React 16. Prior to React 16, when I created a component, from its render method, I could only export a single parent element. And what that meant is if I created smart lists or smart tables, I sometimes had trouble because the quick fix for that was to wrap everything in one div and then export it. But of course, if you do that in a list or in a table, you totally break semantics. But from React 16, it is possible to return arrays of JSX elements. So I can return a full array full of list items, or I can return an array of table rows. And this has been really great in that area to ensure that even there, semantics, the semantic translation from JSX to HTML remains intact. So when you run into this situation, if you're going like, whoa, I've got to wrap it in a div, otherwise my application doesn't work, remember, just use fragments in React 16 and it helps you a long way. The next thing we're going to look at are intact header semantics. Now, on screen, you've got a graphic of the H1 to H3 header hierarchy, and the correct way to use it, of course, you extend that to from H1 to H6. In fact, just for space on the slide is to H3. But if you think back to the component tree that we saw on the earlier slide, and of what a component is. A component I want to reuse everywhere in my application. So if I go and create a component with a hard-coded header level, what happens then? Then I have to make sure that when I construct my component tree, that this component is only used, say I use an H2, I can only use it as a child of a component that contains an H1. And similarly with H3 and so forth. And it really makes it hard to reuse the components, and what people generally do is just hard-code it and not think about the semantics, and what you end up with is a broken table of contents in terms of headers on your page. So I solve that by making the header level configurable. At the bottom, you see some code. It's a very simple component, but it illustrates that I can give the level as a prop, 2, 3, 4, whatever. The component will go and create this header level or the header element on the fly, and it will render the eventual DOM with the correct level. Now it means that my component is configurable. The user of the application can decide what type of header level I'm trying to achieve, and it makes my component usable in any part of my application without breaking this header semantics. Very much related to this would be the use of unique IDs in components. Now, sometimes I definitely need to still use IDs in a React application. For instance, if I want to accessibly label an input. However, similar to what we faced when we looked at the header levels, if I create or if I hard code my my ID in my JSX, what does that mean? Once again, I can only use this component once per page because the ID needs to be unique in the entire rendered DOM at any moment in time. So if I look at my example here, I've got a labeled input. Now the chances are quite large that I would want to use more than one input on a page. I would want to use 15 inputs on some pages. And in order to do that, I need a mechanism to ensure that the ID is unique. So what I like to do myself is to auto-generate this ID on the fly the first time the component is rendered. I use a package called node_uuid. This returns GUID strings that I use as IDs. Now, yeah, you can say that this is quite verbose, yeah, but you can replace this implementation with your own implementation as long as it returns unique strings in your application. So once this component is rendered, it will get its own input or its own ID assigned. These IDs are unique in the DOM, and I have no problems anymore. I hear you say maybe that you cannot anticipate what the IDs would be. Now, that's quite correct. However, in React, we try and strive to creating our code declaratively, which means that knowing the ID beforehand is usually not a problem. And if you do need to know the ID or an ID for something like testing and so forth, or a little bit of imperative code when it's needed, there are mechanisms for. You can use a class as an identifier, or you can use something called a ref, which we'll get to later. Now, a really big issue that we need to tackle, and that is that routing is accessibly silent. Now, routing or routing, depending on whether you prefer the American or British pronunciations, refers to how single-page applications, like the applications we create in React, react to changes in the browser URL and loads in new views. Now, when I create websites with hard-coded with HTML files, what happens then is if I click on a link, the browser will go and fetch the related HTML file, and it will, in essence, do a reload of the browser. What this does as well is it tells assistive technologies like screen readers that something's happened, that I've reloaded, and what the new page is. But if I do that in a React application, if I go and reload the HTML, I totally destroy my JavaScript application state, so I cannot do this at all. And in order to do, to still be able to have navigation-like functionality, I need a little bit of software, and that is called a router. And all that does is, if you look at the page here, there is some JSX code, a configuration of the most commonly used router in React called React Router. It sets up some paths, and if the path matches the URL in the browser bar, it will load the related component into the view. Now, that's great. It simulates the navigation that I normally get outside of a JavaScript application, but the problem is this is totally accessibly silent. Screen readers are not informed at all that this total context change happened in my application. And worse than that, when I click on a link or tab to a link and activate it, focus remains on this link. So in essence, a screen reader user will get no reaction at all, even though the entire application has changed context in state. I can fix this by setting focus after navigation. Now in React, I set focus by using a functionality called refs. Now a ref is basically something that I can attach to a JSX element. I can attach it to a component class, and when that element or class is rendered, it will call a callback function where it will pass the current actual instance of the JSX element or the component class into. In this case, I'm creating a component that I want to use at the end of a route. So when I navigate, this component will render. In there, I've got an H2 element. Now, I didn't make this configurable just for simplicity's sake. I've given it a tab index of -1 so that it can accept focus from JavaScript, and then I'd use a ref on it. When this component gets rendered, it will pass the actual DOM instance of this H2 element into the callback function, and I can store it in my class. And what I can do then, as you see at the top, I can imperatively focus it with JavaScript like I normally would. Refs are not to be overused, but when you set focus, this is the way to do it. You see that I do it in a component.mount method, and that is simply a React lifecycle hook. And the lifecycle hooks in React are functions that are known by React that gets called at specific times of the component lifecycle. And in this case, when it actually got mounted, in other words, rendered completely the first time around. So I've sorted out the focus issue. By setting focus to the H2 element, the screen reader will already read out the text of the element, so my routing is no longer silent. But sometimes, while we are talking about refs, I want to set this focus from outside of the component itself. It's very easy inside the component. And I told you already that class components can also be used with ref. You can't use functional components because they have no instances. But if I use a class component, I can maybe expose a focus method on this component class, and that seems like a great idea until you run into higher order components. And this is something to watch out for when wanting to set focus with refs. But what is a higher order component? A higher order component in React is nothing more than a function that I pass another component into, and what I get returned is yet another component, and it is the result of my original component decorated with reusable logic. And that is one way in React that I can reuse logic over many components without having to copy and paste code. However, even if you never create a higher order component yourself, chances are that you will bump into one of them. And the reason for that is React Router gives us a with router higher order component. And this higher order component then decorates the component with router logic, like the current location where I am, the match criteria, etc. Also, you've heard that React is often used with Redux, a state management engine. And if I use Redux with React, you will bump into something like the connect higher order component that connects my component to the implementation of the Redux store. Now, why is this worthy to mention in this talk? When you deal with focus management, if I set a ref to a component that is the result of being wrapped in a higher order component, I get not an instance of my wrapped component, but an instance of my higher order component class. And that, of course, means that I have no access to any functions I've exposed on the wrapped component or any of its JSX elements. And we can solve that by looking at a little bit. This example I got straight from the React docs. And in fact, this is the recommended method of using refs with class components. This is, in fact, the recommended method of using refs when you are doing it outside of components, regardless if they are class components or functional components. So what I have here is I've got a field component. This ref takes a callback function as a prop. So I've created a new prop on my component, input ref. This accepts a callback function. So after it's wrapped in the hock, from outside I can pass in a callback function. And this callback function on render just receives the internal JSX element instance. And once again, I can imperatively set focus to this element from outside. So really, just go with this method from the start, and you won't have any problems if you either have to create your own higher order components or use already created higher order components. So we are not quite done with the routing problem yet. When I change context in my application with the router, I should actually be updating the document title as well. Now that, of course, refers to what you see in the browser tab. When a screen reader user goes to an already open browser window, that gives the screen reader user context of what is happening on this page at the moment. Now, sadly, once again, if I just use vanilla routing, also the document title is not updated. Why is that? Because this title tag sits in the header of my HTML document, while the React application will be running in the body of my HTML document. So I have no access to it. I can go change it imperatively, sure, but why not just use something that is already available on NPM? And what I use myself is something called React Document Title. It's created by Dan Abramov, works brilliantly. It exposes a document title component. And when I render this component and give it a title prop, it will go and set the document title of my current HTML, of my current browser page to this text. So what I've now done is I've not only solved the issue of focus, I've not only solved the issue of the screen reader being silent, but I've also solved the issue of the document title not being set. Great. However, sometimes I want to tell the screen reader a little bit more about what's happening in my application. And then we turn to ARIA Live. Now, for anybody that's built JavaScript applications and looked at accessibility, you will already know about ARIA Live, and you will see soon why I'm mentioning it in this talk. Just a quick layout or explanation of what it is. ARIA Live gives us the ability to decorate an HTML element. It becomes a live container, and when the content of this container changes, that change gets sent to screen readers, and screen readers will read it out. So if you think of, say, for instance, in my routing example, that reading out the H2 element is not enough, I can add to it by sending a live message to the screen reader. Or say that I'm fetching data from the server. When this data comes back, I get a total application state change, and this is visually quite obvious, but for a screen reader user, he or she may not know that something has happened on the page. And I want to send a message to say, hey, your data is in, go and look at this and that. And that I can use ARIA Live for. However, when I use it in an application that uses components, what happens now? Typically, the easiest way to do it is to render the ARIA Live right where the change is happening. But the problem is that there is a gotcha, because ARIA Live regions, when they are not already rendered on pages, some screen reader browser combinations will not read out the text that it contains when it is rendered the first time. So you want this ARIA Live region to be rendered as quickly as possible and to stay rendered for as long as possible. So if I'm doing it in a child component far down in the component tree, there's a lot of changes happening there, and typically it means that I may be rendering and removing and replacing components, and that is not a great place to put the ARIA Live region, as many of the changes will be swallowed. Also, it just complicates your code, because you have ARIA Live happening all over in the application, and that is very hard to think about. So I actually want it to be rendered as high up in the component tree as possible, and preferably in the root component, because if I render it there, my ARIA Live region will be rendered when my application starts, and it will stay rendered for the life cycle of my application. But unfortunately, communication in React between direct parents and children in the component tree, that's easy, but communication from a parent to a child far down, or vice versa, is quite hard. And there are complex React APIs that make it possible, but why go do that when I've created a package for you? I thought about this long and hard, struggled with it myself, and I came up with the React ARIA Live package that you can pull down from NPM. All you have to do, it exposes two components, live announcer and live message. If you render or wrap your entire component tree in live announcer, it will render the ARIA Live region for you and keep it rendered. And when I render the live message component, either the first time with a message prop, or if I go and change the message prop, it will send those messages to the live announcer regions, and that will inform screen readers. Go and use this tool. If you see anything that can be improved, please have a look at it on the GitHub, on my GitHub repo. Log issues, log improvements. I found that it works very, very nice in the applications that I've wrote and I've written, and I trust that it can help you too. So the next step, we've now looked at tips and tricks, but how about tools that can help us as React developers to create more accessible React applications right from the ground up? And the first thing, strangely enough, that I will refer to is create React app. Now, this is a CLI that was created by the React team themselves, with which I can bootstrap new React applications. So I pull it down from NPM, I create a new React app with it, and I can instantly start this React app. And it comes with a lot of benefits. First of all, it comes with a Webpack development and production build. The development environment has live reload implemented, so any change I make to the code is immediately recompiled, and you can see it, the changes on screen immediately. And really great, it comes with some accessibility rules already implemented. More on that a little bit later. You get progressive apps by default, but progressive in terms of service workers and offline apps. It supports code splitting, so it helps you to improve the load performance of your applications, and unit tests and coverage is already in there. It really gives you a great springboard because it takes so much worry away from you in terms of configuration, and it also provides you already with some accessibility goodness, and that comes in the form of a plugin for ESLint, and it's called ESLint plugin JSX A11Y. Now, ESLint is a linting program that we use to check our ES6 JavaScript code for errors. It's configurable, and what this plugin does, it adds some accessibility goodness to ESLint that is not there out the box. And on the website, it's called a static abstract source tree checker for accessibility rules on JSX elements. When you go to the website, you see that there are more than 30 accessibility checks for ESLint and for your JSX. Here are some on screen. If you go to the website, you can get the exhaustive list. If you use Create React App out the box, a number of these checks are activated by default. Of course, you cannot activate all the apps because the idea of Create React App is that it can be used in any application environment for any application, and sometimes it can be too restrictive to estimate what the users want to do. But you can eject from Create React App, and then you can configure the rules. Or if you use this plugin in your own ESLint implementation, the rules are also fully configurable. So you can set any number of rules on or off. You can change the level of either it's a warning during compile or it's an error. I can also, even if I haven't ejected from this Create React App ecosystem, I can extend the configuration so that I can plug it into my IDE later. And in a moment, you'll see what that does. But first, we'll have a look at what if I have ESLint running as part of my React build, and that I get, again, out of the box with Create React App. Any of this tool will go and evaluate your JSX. Any issues with the JSX that it sees with any of the rules, that will immediately be reported as part of your compile step. Now, this is virtually instant feedback. To make it even more instant, I can integrate it with some IDEs. I integrate with WebStorm, works perfectly. And this is a screen cap from the IDE integration in WebStorm itself. Then, of course, I can extend the rules with the configuration I showed you, but you get instant feedback from this linter in your IDE itself. Now, closer to the source, you cannot, you really cannot get. What I've done here is, instead of area hidden, I went and wrote area hidden, and immediately I get a pop-up or a red line under the code. And when I click on it, I get some feedback of, did you mean to use area hidden? Really great, this tool. I would not write React JSX code without it. But of course, there is a limit to it, because what this tool can do is it can check various components. It can only check the JSX on a component level. It cannot estimate the composition of my component tree or how I'm going to eventually be using my components. That is not its purpose, and we need to have something that fills this gap. And for that, I use ReactX, and that provides accessibility auditing for React.js applications. It was created by the folks at DQ Labs, and it runs on the magic of Xcore. That, of course, is the same magic that I get when I load the X audit tool in my browser. But I can bring that power straight to my React app by doing some configuration. And this shows you how. This is some code that shows how I bootstrap a React application to start with, but then I add a little bit of code by pulling down React X from NPM. And I wrap my React DOM or my virtual DOM, as we saw earlier, I wrap that in React X so that it can go process it every time this DOM changes. I also have a delay. You see here 1,000 millisecond delay. And the reason for that is I want my application to be stable. I want this translation from virtual DOM to actual DOM to be completed before I do an accessibility check on it to avoid false positives or even false negatives for that matter. And you also see that it's hidden behind a production flag. And the reason for this is you do pay a performance price by using React X. So you do not want to run this in production. And least of all, you do not want to be writing console error messages to your browser console in production that I found accessibility errors on the fly. What is the result of this? This is a screen cap from Chrome browser's console, and it shows a number of accessibility issues that it found in a test app I created. And now you must think about this, that I mentioned that with Create React App or with the proper configuration, you have live reload. That means the moment I change code in my React app, it will go and recompile. Instantly, I'll get the ESLint warnings, and it will also go and automatically reload the app in my browser. And a second after that, I will get feedback from X core if there has been any issues in the total composition of my React application. But then, of course, the real power is in combining it and showing you what the result is. And here is another screen cap of exactly that process. What is interesting here is that at the top, you will see a warning that comes from React itself. Yes, as I mentioned, all ARIA attributes are valid JSX props. And because React has that in the spec, it also does some checks on it. And if you do something totally stupid, React will already warn on ARIA. Then I see my warnings coming from the linter. And finally, I see any issues that React X found. So that really is a one-stop shop, instant feedback to the developer that something is going on in the application. I really recommend you to try out this configuration if you're going to be writing some React code. It works really brilliantly. Just one last thing, React X works best in Chrome browser, so you're going to want to be using this tool in Chrome browser specifically for your tests. And then finally, I don't know how many of you are aware of it, but for a couple of months already, React has had its own page on accessibility in the official docs. If you want to do anything with React or already doing anything with React, I invite you to go and visit that page. There's a lot of information on there, a lot of general accessibility information, but how it relates to React. There's some great links that you can visit on that page. You also see some of the things you saw in this talk on that page. But the most important take home is that because React lives so close to HTML, if you carefully construct your applications that way, you can pretty much use everything that is out there on accessibility, all the information that you find on constructing accessible apps, you can translate into your React apps, and React won't stand in your way if you don't stand in its way. And after all of that, I hope that you can agree with me. We've got the original crew of the Starship Enterprise here looking at each other and going, accessibility in React, it's only logical. And that's the end of my presentation. The presentation is already online on my blog, so you can go have a look at that. Thank you so much for your time, for your interest, and I believe it is now time to hand over to the presenters for some questions.
Yes, thank you very much. That was an excellent talk. I have to admit, I'm not much of a React person. I'm still struggling to understand HTML sometimes, apparently, according to my colleagues. But yes. But no, it was very insightful, and it kind of touched on the points that we talked about previously, where there still seems to be that stigma of anything to do with JavaScript is an accessibility no-no. Whereas this clearly demonstrates, as we know, that it's not JavaScript itself that's a problem, or frameworks such as React or Angular or any of those, if used correctly, and authors still needing to have a basic understanding and implementing things appropriately So that was excellent, excellent.
Thank you. And yeah, you hit the nail right on the head there. That's exactly what it's about.
Yeah.
Just a bit of knowledge goes a long way, and then you can use the best of both worlds, really.
Yeah, perfect, perfect. As is the case with many of these things, isn't it? Right, we had a few questions come in from the Twitters, so let's have a look. The first one from Seth Swanson, writer Seth, and he's asking about the routing techniques. How do these routing techniques interact with accessibility scanning tools like SiteImprove?
Honestly, I haven't tested that myself. So yeah, I hesitate to give an answer on the question if I haven't tried it myself. But you can expect that anything, yeah, that typically if you're going to change the DOM, anything that you would typically expect from changes in the DOM with those tools, that you will get a similar reaction from React. Pardon the pun. I know it's not much of an answer, but I will not venture down that road unless I've tried it myself.
No, you're a wise choice. I mean, I know from experience that, you know, the big differentiation between automated testing tools like services is, you know, if they're actually running a headless server somewhere behind the scenes, because otherwise you can submit something, and if it just essentially grabs what the view source would be for that page, rather than the live DOM, then you might get a warm feeling because you're getting a thumbs up from the tool saying no accessibility problems. But it's only because at that point, all it saw was the HTML and the single script tag that is about to actually launch the application.
That is, of course, something to take into account also when you think about search engine crawlers and so, that you want to think about how do the search engines go about, does it unpack my whole application? Because there's a good chance that it's not going to find a page that's hidden behind a router somewhere deep in your application. So there are, of course, ways around it. You can do server-side rendering. You can provide some, of course, if you think about the React app itself, it will go and replace the content of a tag in your HTML. So if you write static HTML in that tag to help some tools along while the React application is loading, that is also possible. And once, progressive enhancement step, that once the JavaScript is loaded, it will go and replace that. But it is definitely something to think about in the wider world, even beyond the assistive text, but search engines in general as well.
Yeah, and I believe I remember you showed 10 on early on in the presentation. That would be an example where, as far as I know at least, it's running an actual headless server and it's querying basically the DOM as a browser would understand it. So all the JavaScript kicks in and everything else. No, excellent. And another question from Martin Peters was specifically about the focus function that you showed. And the question was, why not use an autofocus attribute on an element instead of the method that you just explained?
Autofocus, with autofocus, I don't have the control over the focus. Now, there I showed an example where I did want to focus something at the moment the component loaded, but that is specifically for routing. But if I use a ref, I've got more control over when it happens, and autofocus has been known to confuse screen readers. So the ref is really the recommended way within React. I know some people go and focus it even through the React DOM itself. But yeah, focusing is best done with the ref because I get a handle to the component, and then I can choose the moment that I want to focus it. I can, for instance, make sure that if it's in the lifecycle hook component did mount, I know that my component is fully mounted, where autofocus will trigger the moment it hits the browser. So it's more a thing of control, that I'm then in control of when I'm focusing, and then I can make the decision at the right moment of the application lifecycle.
No, excellent, excellent. Right, let me just double check. Yeah, I think that was it in terms of questions. So I'd like to take the opportunity to thank you again for taking the time to take part in our ID24. Now, for each session, we pick the best question tweeted to the hashtag, and the winner receives a free 90-day JAWS license. We're having a bit of a debate internally, but I would say for this session, the winner is Martin with the autofocus question that we just answered. Now, a reminder that ID24 is brought to you by the Paciello Group with kind support from Barclays and the Center for Inclusive Design. You can find out more about those organizations on our website. If you like this session, hit that like button and subscribe to the ID24 channel for future event streams and videos. We're going to take a short 10-minute break, and hopefully we'll see you all for the next session. But in the meantime, thank you very much.
Thank you to you as well.
Thank you.
Great experience.